In this lesson, we're going to look at how to write exponential functions and how to identify their critical attributes. We're also going to look at graphing. So a lot of things going on in this lesson. So first of all, let's look at the definition of an exponential function. It says an exponential function is a non-linear function written in the form y equals a times b to the x power. And a cannot be 0, b cannot be equal to 1, and b has to be greater than 0. If these things don't happen, then it's not going to be an exponential function. Okay, so first, let's talk about how to write an exponential function. There's some important things to know about our equation. X and Y are just going to represent a point on our graph, okay? The A is the y-intercept, and I know a lot of times we like to refer to the y-intercept as our starting amount. So if we were looking at a word problem, that would be something that would be helpful to know, okay? B is going to be the change between consecutive, so right in a row, consecutive y values. And that consecutive word is really important. And what I want us to note too here is that when we go to find the consecutive change, this is going to be a multiplication pattern. When we looked at linear, our patterns were adding or subtracting. Here we need to be looking for a multiplication pattern. And another note to make about this is that this b value we're going to look at later in the week is going to also be referring to our growth or decay factor. It's going to help us indicate that. And like I said, we'll talk about that in our next lesson. I'm going to get a couple more markers out here. Okay, so let's start by looking at this first graph. It says write an exponential function. So see how it's curved up. We've actually been seeing a lot of exponential graphs lately in the news, referring to our situation we are in right now. So the first thing I would suggest that might be helpful is to make just a little table here, okay? So I'm going to pick out some points. So first of all, we know our y-intercept is important. So there's our y-intercept. That is 0, 3. And then I want to pick exact points, and I need to try to pick consecutive if we're going to find this pattern. So when x is 1, it looks like y is 6. So 1, 6. When x is 2, y is 12. So that's nice. That's enough. That's all I need to be able to work through this. Okay, so we know our a value. We know our y-intercept is 3. So our equation is going to be y equals, or f of x equals 3. Okay, now what is our pattern between consecutive y values? Remember, it's got to be a multiplication pattern. Hopefully you're seeing that this is 3 times 2, 6 times 2. So our pattern here is times 2. So this would be 3 times 2 to the x power. We wouldn't write that as 6 because this exponent only applies to the 2. So this would be our equation. Okay, simple as that. Okay, now this is increasing. So this is an example of an exponential growth graph, just something to notice. Okay, notice this exponential graph is decreasing. So this is going to be an example of something that might be decaying. Okay, let's make a chart. We're going to need to pick some exact points here between our consecutive y values, and important that we kind of go least to greatest on our x values. So I'm going to go to -2, 12, and I just realized I'm going a little fast. So at any point, stop your video and think about what I just said. And then we've got -1, 6, and then it looks like our y-intercept is 0, 3 again. Okay. Okay, so again, our y-intercept is 3. So we're going to say y equals, or f of x equals 3. Now, this one's a little tricky, and the reason I stress that we need to make sure we put this in order is you may be thinking, okay, to get from 12 to 6, that's dividing by 2. But we need a multiplication pattern. So what's the same thing as dividing by 2? I hope you're thinking multiplying by 1/2 or multiplying by 0.5. So it's got to be a multiplication pattern. And so we would say 3, and our b value is 1/2. 3 times 1/2 to the x power. And there is our equation, right? Super easy. Okay, now that's from graphs. Let's look at a table real quick. So we have an example with a table. Hopefully you see right here, this is our y-intercept. So we're going to say f of x equals -1. And here, what is our pattern? What are we doing to get from one number to the next? And I think you will see we're doing times 1/2. I'm thinking that this might be wrong, but we're just going to go with that for right now. That's the general idea. Okay? Okay, so let's talk about now, that's writing from a graph, from a table. Hopefully now we know that the a value is our y-intercept, b is the pattern or the change between consecutive y values. Okay, so let's look at now the critical attributes. So most of the critical attributes you should already be familiar with. You should already know those: y-intercept, domain, and range. But we have a new one called an asymptote. Okay, an asymptote is just a line that the graph approaches but never actually touches. So if you look at these graphs, it looks like this graph is touching our y-axis, but it's really not. It's getting closer and closer and closer and closer, but it never actually hits 0. Okay, so in this case, our y-axis would be our asymptote. Okay, we're mainly going to be dealing with horizontal asymptotes. So we know horizontal lines are y equals and then our number. But I do want you to know that there can be vertical asymptotes. You will learn those later on. Okay. Now, in order to graph a exponential function, really all we're going to do here is we're going to make a table of values. We're going to use our calculator. You don't have to have a calculator to use this, to do this. Remember, Desmos is a great option, but you don't have to do that either. Okay, so I'm going to clear my, okay. Clearing my graph. We should know, we should be able to tell right from the graph, from the equation, that our y-intercept is 2, right? So I'm going to go ahead and I'm going to put a point at 0, 2. Now I'm going to take our function and I'm going to put it into my calculator, and you can not see it. I'm going to turn my little lamp off. Okay, there we go. We can see that. Okay, I put 0.25 just because I didn't want to fool with the fraction 1/4. I'm going to hit enter just so we can kind of see it. We see that this is decaying, but I want some actual points. So I'm going to pull up my table. And we see that we've got 0, 2. And see, look at these numbers. Look at how they're getting smaller. Let's see if I've got some numbers. Here we go. I can do that one. I can graph -1, 8. So here, I'm going to put this in my table so we can see what we're graphing. We graphed 0, 2. I'm going to plot -1, 8. And that's probably about the only exact one, because look, the next one is negative 232. So let me go back. I've got 1.5. We're at 1.5, so I could probably do that one. And so that's enough for us to kind of get an idea and see that our graph is going and going. Now, what I want you to see here in our table, as my x values get greater, notice this number is getting smaller and smaller and smaller and smaller. Now, at some point, whoops, now I think, oh, that's an exponential notation. At some point, it might level out and say 0, 0, 0. But that's just because the number is so minute, so small, that your calculator can't display it. Okay, so it's approaching the y-axis, but it never actually touches it. So our asymptote, that line that it approaches but never actually touches, would be y equals 0. And most of the time, your asymptote this year is going to be y equals 0. Okay? And so let's talk about our domain. Domain is all the x values. So if our graph is continuing on in both directions, and even though it looks like it's going straight up, it's really spreading out. This would be all real numbers for our domain. And then for our range, we know that our boundary line is our asymptote, y equals 0. And then all the other y values are going up this way. So for our range, it would just be y is greater than or equal to 0. Okay. Okay, so let's look at this next one. This one's a little bit trickier. It's in a little bit different form, and I just did this one on purpose because I wanted you to see that your asymptote is not always y equals 0. So we're going to start out, and I'm going to plug this into my calculator. So let me get that set in, and then I'll show you. Okay. See, here it is in my calculator. I'm going to hit enter. Okay, so this is a little bit different. This is, like I said, not really something we're going to work with this year, but you will work with it. I think probably when you get to Algebra 2 is when you'll see something like this. So I'm still just going to pull up our table so we can get some numbers from our table. You'll see here that we have 3, 0 that we can graph. We have 4, 4. We could maybe do 5, 16. Okay. And then these numbers are just they're getting closer and closer. Looks like our y-intercept is about -2, but not exactly -2. I'm going to put -1.9. And look, we're getting closer and closer and closer. And then at some point, our calculator does just start saying -2. That's because we are so close to, and you can see that, we're so close to -2, but we're not actually touching it. Okay, so let's look at that. We've got 3, 0, whoops, yeah, 3, 0. We've got 4, 4. 5, 16, and then here. So our graph looks something like that. Let me zoom out a little bit. Okay. So our y-intercept, it's about -1.9. We got that from the calculator. Our domain, again, is going to be all real numbers because we're not terminating, we're not ending any points. Our asymptote is going to be this horizontal line at -2, so y equals -2. And then we're going to base our range on that, because then all of our y values are going up from there. So our range then is going to be y is greater than -2. Okay, so please go back, and if there's anything that we talked about too quickly, go back and look at what we talked about.